Okay, so this is the 2023 paper 2 question 2 on your plane geometry. So they tell you prove that angle ABD is similar to angle AFB. ABD, right, is this big one over here. Right, sorry, this line can be drawn a bit better. And my AFB is the small one up here. Okay, immediately we can see that there is a common angle, right? This angle over here. So we tell them that angle. Okay, we always follow the naming. So in this case, I'm just going to follow BAD is equals to FAD. Right, so just double check again, FAD, right, and then BAD. Yeah. Okay, as long as this naming is correct, it will be correct. Okay, so this is common angles. So we have already proven that one angle is the same. Right, and to prove that they are similar, we just need to prove another angle. Right, another angle that is very easy to see is this angle over here. Right, this angle is my angle ABF. Right, so if we see our angle ABF, right, it's ABF, right, by right, ABF should be similar to that of ADB, right, in which it is. Because why? ADB is actually up here, in which if you see this triangle in here, this is actually just following your alternate segment theorem, right? Because you have a triangle, you have a tangent, right? So we can tell them that angle ABF equals to my angle, right? So just follow the name again, ABF, right? So is equals to ADB, right? ADB down here. Then this is because of alternate segment theorem, right? Then since they have two common angles, right, by AA, sorry, triangle ABD is similar to triangle AFB, since two pairs of angles are equal. Okay, so this is how you do question 2A. Then for part B, they tell you a circle can be drawn through B, C, and X, where BC is the diameter. Okay, let's draw this first. So they tell you B, C, and X, right, where BC is the diameter. And let's draw this circle out. Okay, circle is probably a bit smaller to be like so. Okay, then they tell you, sorry, I think can be a bit better, can be a bit higher, maybe up here. Something like this. No, something like this. Okay, then they tell you, what type of quadrilateral is EBFC? Give your reasons to support your answer. Okay, EBFC. Let's take a look. EBFC. Okay, visually this looks like a trapezium, right? And we need to be able to prove it is, if it really is a trapezium, right? And in which we actually can see that actually there's a 90 degrees down here, because our BC is our diameter, right? And BXC is basically angles in the semicircle, right? That gives us 90 degrees, right? And let's see if we are able to prove anything else, right? They tell you that FD, let's see if we have any information about our FB, right? For our FB, let's take a look, right? From our part A, if we took a look earlier, right, our part A, actually we can tell that this is also a 90 degrees up here, right? Why is this also 90 degrees? Well, if you realize, if I erase all of this, do you see that this part over here is actually also the diameter in which we get our angle FBD to also be 90 degrees, right? Because this is again another angles in a semicircle. So let me draw back that circle, right? So we can tell them that angle FBT is equals to 90 cos angles in a semicircle in which this is the bigger circle lah. Bigger circle. So we write here bigger circle. Right? And we can also tell them that angle BXC is also equals to 90 degrees because this is again another angle in semicircle. Okay, sorry, I forgot to put equals to 90 degrees. Equals to 90 degrees. Right, and this is smaller circle. Okay, actually, sorry, I missed out one more word. Right angle in a semicircle. Right angles. Okay, so this is for our second angle, right? And from this we can actually then conclude. Therefore, angle FBX is equals to or more of angle FBX plus angle BXC equals to 180 degrees, right? And this satisfies one of our rules in EMATH, in which this satisfies interior angles, and therefore we can actually conclude that BF is actually then parallel to the line XC. And since XC is actually just an extended version all the way to point E, right, BF is also then parallel to EC. Right, and since BF is parallel to EC, we can therefore then conclude that this quadrilateral BECF, or let me follow their naming. What did they name it as? EBFC. EBFC is a trapezium. Okay, so that is how you do the question 2 of the 2023 paper 2.